sky cascading, the colors are infinite. Feel it now, a new sun glistens, rising within me. We're flying higher than we've ever been. We're flying high. It's a good day for dreaming. There's a hope, there's a spark, there's a fire. There's a light in the dark, burning brighter. It's a good day for dreaming.
Hello, my name is Faith Nylaw.
Hi, my name is Marcus Joseph.
Hi, my name is Emily Weimer.
And I'm Ryan Carpenter. We're the Team Black for the 3D printed aircraft Fall 2025 UCF Senior Design Project.
And over the next couple minutes, we'll be taking you through various aspects of our design. When someone thinks about a 3D printed aircraft, they think of something fragile or experimental. We wanted to break that perception and have it so anybody at home can build one on their desk. Our team was challenged to design a fully additively manufactured aircraft. The aircraft must be capable of flying for 8 minutes, carry a 2-pound payload, and be fully FDM 3D printed. We needed to design the aircraft in a way so that we could 3D print modular components so that it can be all joined together and still be structurally stable. We drew inspiration from the Cessna 208 Caravan, a reliable cargo aircraft. Using common RC aircraft sizing ratios, we selected a 6.5-foot wingspan with a 13.25-inch board. We carefully selected these ratios and dimensions so that the wing loading would stay low so we can maintain its stability in flight. We also chose a NECA 4412 airfoil for its high lift and forgiving stall characteristics. We constructed a simplified CAD model to prove the feasibility of our initial concepts. This model essentially stripped the aircraft down to wing size and shape, fuselage proportions, and tail geometry. This early model allowed us to simulate airflow, estimate lift and drag forces, and validate that our geometry can fly before printing. To explain how we analyzed our model and selected material, here's Emily.
Gotta keep it all in focus. Gotta keep it all in focus.
We started with a 3D CAD model of just the wing in ANSYS Fluent and did computational fluid dynamics on it, and served as a benchmark to then go into SOLIDWORKS flow simulation, where we had an entire 3D printed aircraft model, and then took that and did flow simulations on it to show the cruise, takeoff, and landing cases at various angles of attack. This gave us different velocities, as well as gave us estimates for the electrical power, allowing us to figure out the battery capacity and how long we could fly in flight. Aerodynamics alone cannot guarantee success. Compression testing was done for material selection, where we selected various different infills and different wall loops on ABS and ASA Aero. Ultimately, ABS at 10% infill was chosen, and compared to ASA Aero was a bit spongier, where ABS was compression tested and cracked under load. With this, ABS was ultimately our choice, and with that, I'll pass it on to Ryan, where he'll talk about the final design.
Just let it knock you down. Don't fight it, let it bring you back around.
Now that we had a validated initial concept, we needed to start designing the final CAD model. Starting with the wing, we incorporated a circular ribbed pattern throughout the entire wing span. This allowed us to reduce weight and maintain structural integrity. We also included 2 carbon fiber rods spars all the way through the wingspan as well. This allowed us to mitigate any flexing or bending that would occur during flight. The wing sections were originally fastened together using screws, but that was later changed to adhesives to reduce weight. The final assembly of the wing could then be seated on top of the fuselage. The nose was split into three sections. The first section housed our electronic speed controller, motor mount, and the battery. The second section housed our spherical nose wheel, and the third section was to extend all of those components further forward for center of gravity purposes. The tail was also split into three sections. The next question was, how do we actually bring this aircraft to life? We started with picking our flight controller, and we chose the SpeedyBee F405 wing. We were able to connect our 5 servo motors, the ailerons, elevator, rudder, and steerable nose wheel. We were also able to connect our electronic speed controller and battery to power both the motor and the rest of the electronics. Our flight controller was also able to hold a GPS that can be used for further advancements in our product to allow for navigational flights. All these electronics can be controlled wirelessly. That's where the transmitter and receiver came. The receiver was plugged into the flight controller in the plane, and our transmitter was our controller on the ground for our pilot to use. It was able to send and receive signals wirelessly over a 2.4 gigahertz network. This allowed for a reliable connection over long distances. Here's a detailed look at our final design.
Sliding strong, wow. Turn around and stick it up, wow, wow. Fine specimen, wow. Drop it down now, pick it up, wow, wow. Wow, wow. Drop it down now, pick it up, wow, wow. Wow, wow. Drop it down now, pick it up, wow, wow. Wow.
I will now pass it over to Marcus to tell us about our full-scale prototyping and testing.
I can't catch my breath, I run. Falling deeper, I cannot confess. I can't catch my breath.
With our final design modeled and analyzed, it was finally time to start building our first full prototype. As previously mentioned before, our requirement was to print our aircraft in a print volume no bigger than 256 millimeters. This meant that our aircraft had to be printed in 18 different sections. Our aircraft could be printed in under 5 days. After our aircraft was printed, it could then be assembled by us four in no longer than 7 hours. After it was assembled, we now had our first full prototype. Just after 1 week after we finalized our design, we were able to take our first flight test. After finding this flawed design in our first flight attempt, the team went back to the drawing board. Just after 2 days after our first failed flight attempt, the team was able to redesign and reprint a new nose wheel section. This highlights the capabilities of being able to 3D print aircraft components. Our team was now ready for our second flight attempt. During this flight attempt, our plane used up all the available runway and crashed into an obstacle. This highlighted another flaw in our design: weight. Our plane was too heavy. The team had to go back and redesign our plane to loosen up weight where we could. The first design change was in the wing. The original wing was put together using heat set inserts and fasteners. The team then went back and redesigned the wing to be put together only using adhesives, saving weight. The second design choice was to go back and reconfigure the printing settings. Originally, the fuselage had been printed using a percentage infill of 10%. This was now changed to 5%. Additionally, the wing, which was printed at 5% infill, was then changed to 2. Both the first change and second change helped drop over 1 pound in weight from the aircraft. Our team was now ready for our third flight test. During this flight test, the team removed the 2-pound payload just so our plane could get airborne. Our plane took off without the sugar and was able to fly successfully for 8 minutes. After our plane landed successfully, the team went back and decided to integrate the 2-pound payload back into the plane. During takeoff, our plane was able to successfully fly for about 30 seconds with our 2-pound payload before crashing down due to a major structural failure in the tail of the plane. Our team went back and redesigned the tail section of our plane to give it more structural stability. And this plane is well optimized for printing and now only takes 3 1-kilogram rolls of ABS to print. Additionally, the printing time has been reduced from 5 days to 4 days. 1 month after building our first full team prototype, our team is now ready to fly our final design.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. sunshine on my Sunday best. They feeling good, like I should. When it look all around the neighborhood,
One of the best constructed airplanes I've seen in 5 years.
never stress. Got that sun